And welcome back, everyone, from a much-deserved rest. Let's pick up where I left off. We're doing some application now. So, Vuyo and Sipo's father own a biscuit business called Biscuits for Africa. It is the June-July school holidays, and to make more pocket money, their father has employed Vuyo and Sipo for 1 week to help package the biscuits into boxes so they can be transported to stores. Ooh, a mouthful, eh? All right, let's get stuck into the questions. Vuyo has to pack small boxes of ginger biscuits into the large shipping boxes for transporting. All right, that's why packaging question. There are 600 small boxes, and Vuyo's father tells him he can pack 15 boxes of biscuits into one large shipping box. How many large boxes will Vuyo need? All right, so we've got 600 of these little boxes. They can fit into a large box 15. So what have I got to do? I've got to say, okay, 600 divided by 15 should give me 40 boxes, small boxes. Ooh. Large boxes. I'm just seeing why that's not behaving. Okay, let's go boxes. Right, there you go. So he can fit in, he will need 40 large boxes. Aha, nice work. All right, moving along. Question 2. Sipo has to pack tin cans of chocolate biscuits into the same sized large shipping boxes that Vuyo was given. He's told he can fit 20 cans into one large box. If there are 500 cans, how many large boxes will Sipo need? So, 500 divided by 20 gives me 25 boxes. Nice work. Let's carry on. If each large shipping box costs R5.50, which will be cheaper to pack, the ginger biscuits in small boxes or the chocolate biscuits in tins? So, if you remember from the previous question, all right, Vuyo, all right, for him, he needed 40 boxes. All right, and in this question, Sipo needs 25 boxes. So if the price of the box is R5.50, which would be cheaper to pack? I think Sipo's would be cheaper because he needs less boxes. Does that make sense? I hope so. All right. Nice work, boys and girls. Let's pick up the next one. All right. Vuyo's and Sipo's father tells them that each large box can hold a maximum weight of 3.5 kilograms. All right. Mass. If each small box of ginger biscuits weighs 200 grams. Okay, so there you can see we're dealing with grams here, we're dealing with kilograms there. We're likely to do a conversion. How many small boxes can Vuyo pack into a bigger box without exceeding the weight limit? So in this case, we've got to convert from grams to kilograms. That's the first thing we've got to do. Always do the conversions first, right? So in this case, there are 1,000 grams in 1 kilogram. We have 200 grams, so therefore 200 grams divided by 1,000 gives me 0.2 kilograms. Yes. There we go. Nice work. All right. So what do we need to do now? We need to take the 3.5 kgs. All right, let's just write that a little bit lower. Okay, therefore 3.5 kilograms. Yes, we've got to divide that by 0.2, and here, my answer, I get as 17 boxes, so that he doesn't exceed the limit. All right, nice work. Wow. So with the next one, if each can of chocolate biscuits weighs 300 grams. How many cans can Sipho pack into the big box without exceeding the weight limit? All right, similar to the question before, we've got to convert from grams there to kilograms. So 1,000 grams, okay, in 1 kilogram. And we have 300 grams, so we've got to divide that by 1,000, and that gives me 0.3 kilograms. Check. Then, therefore, the weight, the maximum weight is still 3.5, so 3.5 kilograms divided by 0.3 kilograms, and here I get 11 tons. Excellent work. All right, let's see what's next. The boy's father orders new large shipping boxes that are 45 centimeters long and 16 centimeters wide. All right. Question A, if the surface area of the bottom of one small box of ginger biscuits is 25 centimeters squared. Remember, centimeters squared, it has that symbol because we're talking about area. Excuse me. They are square. There's a shape measuring 5 centimeters by 5 centimeters. How many small boxes can Vuyo fit only one layer deep into the new large boxes? Apologies. So what we've got to figure out here is how many we can fit just at the bottom layer. Now, if you think about it, the bottom layer wouldn't have height. It'll just have length and it'll just have width. So I've got to see how many of these boxes will fit across the length and how many boxes will fit across the width. Multiply the two together. That will tell me how many can go across the bottom layer. Nice. Very, very nice. So let's get stuck into that. For the length, all right, we're going to say 45, okay, centimeters long. There it is. I've got to divide that by the length of the box, which is 5. There, that one. And that gives me 9 boxes. Okay, let's write this 9 a little bit better. I think that looks better. Okay, nice work. The width, all right, across the width, we are fitting 16 centimeters wide. That's its width. So 16 divided by the 5, the next 5 there, if you want to look for it there. And that gave me 3 boxes. Nice work. All right, so finally, to figure out how many of these can fit across one layer, 9 multiplied by 3 gives me 27 boxes. Excellent. Well done. Wow. All right, we're getting there. We're doing something. Question B. If the diameter of one round can is 5 centimeters, how many cans can Sipho fit, again only one layer deep, into the new larger boxes? All right, similar question as the one before. So again, now we've got the circle, we've got the diameter, so we know the diameter fits across the length and the diameter fits across the width. So the length, all right, we're going to say, again, it's 45. All right, we divide that by 5 and we get 9. All right, in this case, that's 9 cans. So for the next one, the width, the width is 16. Come on, 16. That's better. Divide that by 5, gives me 3. Therefore, 9 multiplied by 3 is 27. Again, So in this case, it didn't really matter whether the boxes were the small ginger biscuits or the boxes were the circular cans. Nice work, everyone. Let's take a short break. I think we all deserve it. And when we get back, I'll wrap things up. See you in a bit. And welcome back, everyone. Let me wrap things up. So, if we look at what we spoke of, we started with the assembly diagrams. We went on to working lengthwise across the length of an object, working widthwise, and finally, the packaging stuff, bringing it all together. Then, we spoke of an assembly diagram being the instructions used to help to build something, all right? We also worked in our examples with the screw and the plug and those kind of stuff. Then, the definition here for a plug, part of the end of an electrical cord, the prong, those three little circles, all right? The metal piece that is part of a plug, a screw, a piece of metal with a spiral groove, and lastly, the screwdriver a tool used with screws. Aha. All right. Then, common errors. Remember to read the questions carefully and to make sure to convert, I apologize that I jumped ahead a bit, to convert, there it is, when necessary. And I can't stress it enough, we've got to read, we've got to focus, we've got to concentrate, we've got to know whether we're working lengthwise and widthwise and with diameters and all that stuff. But I know you guys got this. I believe in you guys. Now, the challenge. Can you think of a disadvantage of an assembly diagram without words, like the one on that side? Thanks everyone for listening to me today. I really hope you guys learned something. Looking forward to chatting to you guys again. Take care. Goodbye.